This is the mother of all vector problems because it has three vectors. You do it exactly the same. You just have to break all three out into x and y and add all three together to get your sum for your resultant vector. So let's look at this problem. We'll start with this vector, the 3. Our x is our adjacent, because that's our theta, and our y is our opposite. If we look at unit circle with this one, we have 0, 360, 90, 180, and 270. And to remind us, negative, negative, positive, and positive. So the angle that we're looking for here is 80, and that's our theta. So we can tell that our x is going to be very small and our y is going to be close to 3. To find that x, we'll do cosine of theta equals adjacent over hypotenuse. And we get that x is 0.52. And it's positive because it's pointing towards 0 at 0 degrees. And for y, we'll do sine of theta equals opposite over hypotenuse. And we get 2.95. And I'm going to leave it at 2.95 and not round it down smaller so that we can see it's not quite the same as our hypotenuse. And because this is pointing towards 90, it's positive. 2.95 at 90 degrees. So that's one set. We can also do this vector here. It's 4. And we draw our x and y. Theta is going to be here. Our x is our adjacent. And our y is our opposite. If we look over here, we know that this is 350 degrees. So this little bit here has to be 10 degrees, because that's how much more it would need to get to the 360. So our theta is 10. We would say that our cosine of theta equals adjacent over hypotenuse. So we have 3.9, and because it's pointing to the right towards 0, it's positive. And we can do the sine of theta equals opposite over hypotenuse. And we get that our y is equal to 0.69, and it's pointing downwards, so it's going to be negative. So now we have two. So now we have two of our vectors broken into x and y. We can do one more. We have 2.5. Our x and our y. So x is adjacent and y is opposite. Now I have to find out what theta is. So we know that from 0 to this is 250 degrees. And we are trying to find this piece right here is theta. So this part is 180. How much more than 180? It's 70 degrees over 180. So our theta is 70. So our cosine of theta equals adjacent over hypotenuse. Because it's pointing towards 180, it's negative 0.86. at 180 degrees. We could say the sine of theta is equal to opposite over hypotenuse. So our y is equal to 2.3, and because this is pointing down towards 270, it's also negative. So now we can sum them. For the x, this is where your positive and negative signs become very important. Positive 0.52 plus positive 3.9 plus negative 0.86. And you can put it straight into your calculator like that. And you get positive 3.56. And because it's positive, we know that that means it's at 0 degrees. For our y direction, we have positive 2.95 plus negative 0.69 plus negative 2.3. And we get negative 0.04, so this is tiny. And because it's negative, we know that it's at 270 degrees. I'm going to scroll down to get a little bit more space. So we can draw these now. Our x is 0, so it goes this direction. 3.56. And our y is tiny, but I'm going to make it a little bit bigger so that we can see our numbers and such a little bit easier. And that will be our theta. So we can find the magnitude with the Pythagorean theorem. And you get that it's 3.56022247. And we should have realized that it was going to be pretty much the same number because this is so very small. So for our theta, we'll do tangent. Theta is opposite divided by adjacent. And we get that our theta is 0.64 degrees, or if we round it to a whole number, 1 degree. Which again makes sense because this is very tiny. If we put this into unit circle, 0 / 360, 90, 180, and 270. And we want to know all this way around. We also know we are 1 degree short of 360. So our resultant is 3.56 at 359 degrees. And our equilibrant would be exactly opposite, so minus 180 degrees. We'd have 3.56 at 179 degrees. So I could give you 5 vectors all together and ask you to find the resultant, and you could do it. It might take you 5 sheets of paper, but you could do it. Please ask for help if you are really confused on this. This seems like it doesn't have anything to do with physics, but now we're going to start using these in word problems. So we're going to combine kinematics, motion, and do it two-dimensionally. So when you kick a soccer ball, it goes up and out. And we're going to be able to break these velocities and forces into X and Y dimension and tell things about the motion of these objects. So it's very important that you understand this vector part, because we're going to now combine it with the motion stuff, and then after that with the force stuff that you've learned in previous chapters.